Hello dear students, in this video we will be discussing about degree of kinematic indeterminacy, or we can say degree of freedom. Okay, so first we have to understand what is degree of kinematic indeterminacy. So it refers to the total number of independent available degree of freedom at all the joints. Okay, so it is denoted as dk, and we know the degree of kinematic indeterminacy may also be defined as a total number of unrestrained displacement components at all joints. Okay, if we are having one joint, that is fixed joint, then a fixed joint will be displaced in neither x direction, neither y direction, or neither in rotation in mz direction. Okay, so by means the degree of freedom of fixed joint is 0. Okay, if I am considering your roller support, then roller support, one reaction is acting normal to the support, then our roller support will displace in via x direction and also in rotation in z direction. So we are having 2 degree of freedom for roller support. Okay, if I am considering hinge support or pin support, then the total reactions on hinge support acting as one horizontal and one vertical. So therefore our hinge support will displace in only mz direction. So degree of freedom for hinge support will be of 1. Okay, so we have to keep in mind the different types of supports, and based on that the degree of freedom will be decided. Okay, so here see this table, this is our type of joint, 2D truss joint, and possible degree of freedom we are having for 2D truss joint are 2, that is delta x and delta y. Okay, so you have to keep in mind that for 2D truss joint we are having 2 degree of freedom, and for 3D truss joint we are having 3 degree of freedom, delta x, delta y, and delta z. Okay, and for 2D rigid joint we are having 3 degree of freedom, again delta x, delta y, and rotation in z direction, that is delta x, delta y, and delta z, theta z, sorry. Okay, and for 3D rigid joint we are having 6 degree of freedom available, that is delta x, delta y, delta z, and theta x, theta y, and theta z. Okay, so this is important table, and based on this kinematic indeterminacy will be solved or degree of freedom will be solved. Okay, so you have to keep in mind the 2D truss joint, 2 degree of freedoms are available. Our 3D truss joint, 3 degree of freedom are available. 2D rigid joint, 3 degree of freedom are available, and 3D rigid joint, 6 degree of freedom are available. Okay, so kinematic indeterminacy or degree of kinematic indeterminacy is nothing but your degree of freedom. Okay, and based on that the degree of kinematic indeterminacy for your plane truss, for plane truss means your 2D truss. So we know in your plane truss or pin jointed plane truss, each joint is having 2 degree of freedom, such as delta x and delta y. So therefore, we are having j number of joint in that, and will be having 2j degree of freedom. Okay. So we know that REB the support reactions. Hence, at the support, joint displacement will not be available in the direction of reaction. Okay. So therefore, your total number of unrestrained displacement component at all joints will be your 2j minus re. Okay, so therefore dk is equal to 2j minus re, because we are having 2 degree of freedom are available at each joint, and we are having j number of joint in the truss. So 2j minus re is your external support reactions. Okay, so 2j minus re will be your number of unrestrained displacement component at all the joints. Okay, so for 2D truss you have to remember 2j minus re, and for space truss we know the formula will change with 3j minus re. Okay, so dk is equal to 3j minus re, and we are having, if we are having a rigid jointed plane frame, then dk is equal to 6j minus re, because we know for rigid jointed plane frame or degree of freedom available are 3, that is theta x, delta x, delta y, and theta z. Okay, so 3 degree of freedom are available for rigid jointed plane frame, and also for rigid jointed space frame our formula will be 6j minus re. Okay, because we are having 6 degree of freedom, delta x, delta y, delta z, theta x, theta y, and theta z. Okay, so here the note is that in above analysis all the members are considered axially inextensible. Okay, so all the members are considered axially inextensible here, and all the above displacements are elastic displacements. Okay, so the members are having elastic displacement, and all the members are axially inextensible. Okay, so if we are having rigid frame, okay, so rigid frame, so look at this special case one. If we are having rigid frame, then some of the members are axially rigid in that case, and then axial displacement in such members may not be available. Okay, so our degree of freedom will be reduced in that case. Okay, So look at this formula that for 2D rigid jointed frame, we are having some axial displacement, or we are having some axially rigid members. Then our degree of freedom will be reduced. Okay, so how it is? So dk is equal to 3j minus re, okay, minus m double dash. It is not m dash, because previously in static indeterminacy we denoted m dash as number of members meeting at hybrid joint. Okay, so here we are considering m double dash. So m double dash means number of axially rigid members. So for 2D rigid frame, dk is equal to 3j minus re minus m double dash, and for 3D rigid frame, dk value will reduce as 6j minus re minus m double dash. Okay, so m double dash means number of axially rigid members. Okay, and in previously static indeterminacy we studied that m dash means your number of members meeting at hybrid joint. Okay, so now based on this, some examples are here for kinematic indeterminacy. Determine your dk value for the cantilever. Okay, if beam is axially flexible. Okay, so this is your cantilever beam. A fixed support and B is your unsupported. Here B free and free support. Okay, so free end is unsupported. Okay, so we know for that if we are having beam is axially flexible, then dk is equal to 3j minus re, and j is equal to number of joints, one joint here, and j is equal to 2 number of joint at B also consider. Okay, because we know the significance of j means the number of all the joints, that is supported joint, unsupported joint, pin joint, hybrid joint, rigid joint. Okay, so A and B both are considered here, and this is a unsupported joint. So 3 into 2 minus re value is 3, that is 3. One horizontal, vertical and movement here. So dk is equal to 3j minus re is 3. Okay, so if we are having beam is axially rigid, then our member, that is this AB member, is axially rigid. Then our formula will change like 3j minus re minus m double dash. M double dash we know number of axially rigid members. Okay, so we are having only one axially rigid member here, AB is. Okay, so 3 into j number of joints, one joint and two joint here, unsupported joint also consider here. So 3 into 2 minus re, external support reactions are 3 for fixed joint here and no support here, so we are not having any external support reaction at B, and m double dash value is 1, so 3 is 6 minus 4 is 2. Okay, so based on this, beam is axially flexible, so we are not considering m double dash value, and dk value will not reduced. Okay, and for axially rigid members, our degree of kinematic indeterminacy value is reduced. Okay, so next example is, now consider this given beam. This is a hinge support and this is a B hinge support again. And find your dk value when member AB is axially rigid. So number of joints we are having 2 and RE value is 4. 2 here at A, 2 here at B. So dk is equal to 3j minus RE. So we know for dk is equal to 3 to 6 minus 4 is 2. Okay, so we know the theta A rotation at this joint and rotation at this joint means your degree of freedom. Okay, so if we consider AB as axially rigid, then our dk value will be same as previous case, because axial displacement are already restrained by reactions. Okay, so if we are considering restraint, then B support and A support both are restrained. Okay, so dk value will be 2 only. So based on this, certain examples or numericals. Okay, we have already discussed this. And special case 2, if we are having your rigid jointed frame, then some of the joints may be hybrid, then additional degree of freedom will be available and dk value will increase. Okay, if we are having some internal hinge or hybrid joint, you can say. Okay, so then additional degree of freedom will be available. So in that case, for 2D rigid jointed frame, dk value will be 3j minus re minus m double dash plus rr, and dk value will be increased and release reaction will be considered. Okay, on release reaction will be calculated, you know, for 2D structure summation of m dash minus 1, and for 3D structure summation of 3 times of m dash minus 1. Okay, rr value, and m double dash value we know the number of axially rigid members, and m dash in this case is number of members meeting at hybrid joint. Okay, so for 3D rigid jointed frame, our formula will be 6j minus re minus m double dash plus rr. Okay, rr will calculated as this only, m dash minus 1 for 2D or 3 times of m dash minus 1 for 3D, and m dash and double dash means number of axially rigid members, and re is the number of axially number of external independent support reactions, and j is the all type of joints including supported joint, unsupported joint, hybrid joint, or your rigid joint. Okay, So based on this concept, we will solve in our next video some examples or some numericals. Okay, thank you so much.